This is Secure Software Supply Chains for Python, for PyCon US 2021. So I'm Dustin. I'm a few things. I'm a developer advocate at Google. I'm one of the directors of the Python Software Foundation. I'm also a maintainer of the Python Package Index. And the package index is something you might have been hearing about recently in the news, which is sometimes a good thing, sometimes a bad thing. So here's one, PyPI and GitLab dealing with spam attacks. Doesn't sound great. How about Python Package Index nukes more than 3,000 malicious libraries after a security shortcoming? That's not great. How about this one? New type of supply chain attack hit Apple, Microsoft, and 33 other companies via PyPI. So this talks about the software supply chain, and you might be asking, what is this? And by supply chain, I don't mean a literal physical supply chain, right? We're not talking about producing goods, but it's sort of the same sense for software. We're talking about a software supply chain. And so a software supply chain is really everything that it takes in terms of software to produce your software. So a software supply chain is all of your third-party dependencies, the places those dependencies are distributed, everything used to build those dependencies, all their external dependencies, the places those dependencies are distributed, and everything used to build those dependencies. So as you can see, it's turtles, even more turtles all the way down. And this could even extend to the source control repository that you use. You could consider that part of your software supply chain, or the FTP server that you host your software on once it's built, or the identity server that you use to authenticate people on your team who are allowed to commit and push new changes to your software, or who can't. So if you're a Pythonista, a Python software supply chain might look something like this. You might depend on some third-party packages or libraries like Flask or Pandas or something like that. You might get them from a software repository like PyPI, the Python Package Index. And those tools might use things like setup tools, wheel, twine to actually build that software that you're consuming. So that's a software supply chain. What is a secure software supply chain? And it's basically all of those things, and also they're definitely not compromised in any way. Let's look at what this means with some examples of supply chain attacks, specifically how they relate to Python and Python ecosystem. One type of supply chain attack that we could consider here is a man-in-the-middle attack. If at any point someone can get between you and the place where the software is stored, the place where you're expecting to get software from, and either change it or modify it or in some way compromise it in that process, that's a man-in-the-middle attack. So if you're a Pythonista, a man-in-the-middle attack might be you asked for something to be downloaded from PyPI, someone is looking at your internet traffic and they are somehow modifying it or trojaning it or backdooring it in flight. So what they're actually giving you is something that's not what you asked for. Another type of supply chain attack that we see fairly frequently is typosquatting. So here's a recent article published by Sneak, which is a security organization. And basically, the way the typosquatting attack works is, PyPI is this open repository for packages. Anyone can register any package name. And so that means that some popular package names, when you're pip installing it, you could potentially make a typo. And you could potentially be installing some other package that isn't what you asked for. And these typos can be not so noticeable, right? So this particular example they're showing here is a jellyfish with an I instead of an L. So that would be hard to actually mistype in your keyboard, but there's others too. A very popular package is requests, and there are packages like request tastes on PyPI. Now this package is on PyPI, it didn't take me too long to find, but it's not actually malicious. It's actually someone that's trying to look out for you. They know this is a common typo, and they've gone ahead and squatted it. So usually when we find something like this, we go and we block it, and we make sure that it can't be registered again. But there's an infinite number of possible typos for a lot of the possible and popular package names. So we can't always do that for every single one. So another type of supply chain attack is what we're calling dependency confusion. And this is somewhat similar to typosquatting, but it's almost taking it to the next level. And the community was sort of made aware of this in a big way recently, earlier this year, when a particular researcher found a way to compromise a lot of large software companies as a result of this pattern. And the way it works is that a lot of these companies have software, maybe internal packages or things that they don't want to open source or share with the rest of the world. And they host those on internal package indexes. So for example, if they're a Python house, they might depend on some third-party packages on PyPI, but they might also publish their own private packages to an internal index. And then they configure their pip that they use when they install their software to look at PyPI for certain packages that are there and look at their internal index for certain packages that are there. And so the way this compromise sort of works is it's possible to determine which internal package names these companies were using and register those packages externally on PyPI. And if they had misconfigured pip in a way that it would prefer the packages on PyPI over the same package name on the internal index, they could be compromised because those packages would then be preferred from PyPI, installed from PyPI, and that wouldn't be the package that they were expecting, and it could potentially be something very malicious. Now, in this example, is mostly a proof of concept for him to collect a security bounty, but a bad actor could have used that to their advantage. Another supply chain attack is what I'll call being the target of research. And this makes me glad that I procrastinated a little bit to give this talk because this was actually just recently, the other day in the news, where a particular researcher at the University of Minnesota was doing research on how easy it was to land compromises in the Linux kernel. And you think of the Linux kernel as something that's really well reviewed, something where it's super hard to get security problems into. But they were accused of sending buggy patches in the name of research to see if it was possible into the kernel, and they were somewhat successful in doing it. And another supply chain attack that I'll add is what I'll call getting SolarWinded. So I think a lot of people have at this point heard of SolarWind and that particular attack. And this happens when a large nation state is motivated to compromise not just one software system, but a lot of software systems. This has been called the worst cyber attack, the worst nightmare cyber attack, and it was actually a truly huge attack. But ultimately, it was not about the actual packages themselves being compromised in the way that maybe the Linux kernel was compromised. It's ultimately about compromised building infrastructure. So the infrastructure that's used to build the code before it even gets distributed was compromised. SolarWinds was distributing this software to their customers. The software itself was signed, delivered, exactly as they said it was. The signatures matched, the hashes matched, but before it had even been packaged up to be released, it was compromised just before that had even happened. So this sort of falls into a category of other kinds of like upstream attacks, right? Your maintainers could be compromised. They could be working for a 3-letter agency. You could have a compromised source control system where you don't actually have full control of the software in your repository. You could leak your passwords or your API tokens that you use to commit to a software repository or upload your packages to a package index. And you could also just be the victim of social engineering. Someone could convince you that they're a great maintainer, and you could add them to your project because you have a high workload, and then they could go and compromise it. So, and on top of this, there's just regular old non-malicious bugs, right? We're all human, we're all software engineers. We could introduce bugs that introduce compromises as well that we're unaware of, that weren't as a result of maliciousness, but just sort of happened. So what can we do to have a more secure supply chain? Now, I'm going to think mostly specifically about the Python ecosystem here and what people who work with Python can do to have a more secure Python supply chain. So one thing we can do is just HTTPS everywhere, right? HTTPS and SSL allow us to avoid basically the entire class of man-in-the-middle attacks. Assuming that those are working as we expect them to, we don't have to worry about someone getting in between us and PyPI. So we did this already. We did this 4 years ago. We made PyPI HTTPS only, basically to mitigate the potential for a man-in-the-middle attack. Basically, now that every time you interact with PyPI, it's over HTTPS, and you can be sure that the response you're getting was actually delivered from PyPI. So this is great. It's sort of an easy win that we turned on a long time ago and has been in use ever since. Another thing that we can do as Pythonistas to secure our software supply chain is to use lockfiles. So lockfiles are actually incredibly powerful, but I don't really see them being used quite as much as I would hope them to be used. And they're powerful because they actually probably could have prevented almost all of those supply chain attacks I just described. Not all of them, they can't prevent the ones where your maintainers are compromised, or maybe your build system is compromised. But any man-in-the-middle attack, any typo squad attack, anything like that could be mitigated with lockfiles. So some of the important components of a lockfile. First, version pins. So a version pin means that each package is pinned to one specific version. It's not a range of versions. It's not completely unversioned. It's one specific version. And what that means is that that version that you're requesting from PyPI is exactly the version and is never going to change. If a new version is published, you're going to get that same old version until you bump the version in your lockfile. Another important component is hashes. So hashes are, a means of verifying that the file that we've downloaded from PyPI and we hash and come up with compute the hash independently is the same as the hash that PyPI computed when it was uploaded by the author. And that verifies that the package wasn't manipulated or changed at some point, or that, this with the dependency confusion attack, that potentially we're installing the same version that we thought we wanted, but it's actually giving us a different file from a different index. And the last thing is a full dependency tree. So version pins and hashes are pretty useless if we're only looking at a subset of the packages that we actually need to deliver our software or that we depend on. So a full dependency tree means that not only do we have version pins and hashes for all of our top level dependencies, everything that we're actually installing, but for all the sub dependencies, their dependencies, everything all the way down, literally every Python package that might get used to run or install this software. So let's look at some things that we already kind of use in the Python ecosystem and try and figure out if they're lockfiles or not. So something that's probably very familiar and common is the requirements.txt file. So that sometimes looks something like this, right? Let's say this kind of looks like a web app. It's using Flask as its web server. There's Alembic, Bodo, BigQuery, whatever. Is this a lock file? The answer is no. So there were no version pins. We had version ranges, which is good, but that's mostly for compatibility. That doesn't actually prevent us from accidentally getting upgraded to something that may be compromised or insecure. There are no hashes, and that's probably not the full dependency tree, right? I know Flask has some sub-dependencies that weren't listed in that requirements.txt file. So this is far from a lock file. So you might say, okay, I know how to fix this. Pip freeze. I'm going to pip freeze, and I'm going to redirect to requirements.txt. Do not do this. This is an anti-pattern, and I would not recommend anyone do this. And if you're currently doing this, I'm going to show you a workflow that is sort of a better way to do what you're trying to do here. So the reason you don't do this is because you do this and you get something that looks like this. This is a lot. Like maybe you're in a virtual env and maybe you're pretty sure that these are all the packages you need, but you have the potential to introduce a lot of other stuff here. So is this a lock file? Yes, we have some version pins in here. We do not have hashes still, and it's hard to say whether this is the full dependency tree or not. It probably is if I'm running my application locally and I've pip freezed and it works locally, and those are probably all the right dependencies. But there's potentially other stuff in there that I don't even need, that I just installed by accident or as a one-off thing when I was trying something that's not actually a dependency of my application and has the potential to increase the surface area, which I could be potentially compromised. So this isn't really a lock file. How about pipenv install and pipenv lock? Is this a lock file? So if I run pipenv install and install something like requests, and then I run pipenv lock afterwards to produce a lock file, it gives me something like this. And we can see in here that we have not only just requests, but all the sub-dependencies of requests, like URL lib3. So yeah, is this a lock file? Well, you could probably tell by the name, but yes, it has version pins in it, it has hashes, and it has the full dependency tree. Pipenv when you asked it to install requests, it looked at every other thing that got installed when you requested to install requests, and then it put those all in the lock file as well. So pipenv is pretty powerful, but it does have its sort of own form of lock file, and I want to show you what I think is an underused workflow, which I'll call compiled dependencies. And this uses a package on PyPI called pip tools, and specifically the pip compile subtool of this. So if you pip install pip tools, you'll get a tool called pip compile. I think I said that right. So this is really powerful because it actually uses pip under the hood, and actually so does pipenv, but this also reuses the same files and formats that pip uses to to declare dependencies. So the requirements.txt file format can be reused here. And I'll give you an example of what this looks like. So this is one of the requirements files for Warehouse, which is what we use to power the Python package index. That's a web application. And so in this file here, this sort of looked like that requirements file way back when, right? We just sort of listed all of the high-level dependencies that I'm actually importing in this file, and none of the sub-dependencies. And there's maybe some version ranges for compatibility, but no pins. And then what I would do is run pip compile. I would tell pip compile to generate hashes and also output its output into a requirements.txt file. And then I would pass it this requirements.in file. The extensions don't really matter here. You can name these files whatever you want. And then what this produces is a file that looks like this. So it has a nice little header that's a comment that says this file is auto-generated. Here's the command to generate it. It has all of the dependencies I listed and their sub-dependencies and their hashes and a nice little comment that tells me where it came from. So if I was curious why Bodo core is getting introduced, I can see that, oh, that's a dependency of Bodo 3 and S3 transfer, for example, and I can see this for every single thing in the log file. So for Warehouse, it looks kind of like this, and it's pretty nice. And the powerful thing about this is, like I said, it's using pip and pip's existing format. So you might not have seen a requirements.txt file that looks like this with hashes in it, but pip does have a really nice feature that's hash checking mode. And you can configure pip to verify the hashes for everything you tell it to install. And the really nice thing about the hash checking mode is that in order to use hash checking mode, you have to hash check every file. So you don't have the potential for having a long requirements file where most of the things are hash checked, but you've forgotten to hash check one thing that could potentially compromise you. It's sort of an all or nothing thing. So this is great, and I really recommend trying this workflow and seeing if it works for you. If you're not ready to adopt pipenv, or if you just want to continue using vanilla pip. This is also super powerful if you want to deploy an application or something to a cloud provider which might not support pipenv or Poetry or something like that, which also supports lock files. So what kind of things can we prevent with lock files? So lock files definitely prevent man-in-the-middle attacks because we have hash checking mode enabled. They prevent typosquatting because we're not actually, as humans, typing these package names. They are set in the lock file. You've checked them, hopefully, when they got committed, that they were not a typo. And yeah, it basically avoids potential for typosquatting. It avoids dependency confusion, again, because of the hash checking mode. It doesn't prevent you from being a target of research, social engineering, or getting SolarWinded, though. So I'm going to move on to those next. So what's another thing we could do? We could enable something that I'll call vulnerability notifications. So these tend to kind of go hand in hand with lock files, and they are it's a series of services that will notify you about things that change with your dependencies, specifically whether there's new versions or potentially new vulnerabilities in a package that it knows that you're using. So there's a couple services like this that have popped up in recent years. One that's really nice for the Python community is PyUp. They're specifically built for Python. It's super powerful. Another tool is Dependabot. It's very similar. It's a little more integrated into GitHub. These tools are fairly similar. They have some advantages and disadvantages, but you can sort of weigh them against each other. So again, using Warehouse PyPI as an example, one of the really nice things about this is that we get automated pull request notifications whenever there's a new version. And it will go in actually to the file where we've defined our requirements, and it will change that version pin, and it will update the hashes. Now, I'm trusting that Dependabot is securely getting these hashes from PyPI and that it hasn't been compromised, which, it's again introducing another component of my supply chain. But the advantages here are really nice because I'm constantly being upgraded to the latest version. I can merge this whenever I want. My CI and dependency checks get run every single time this pull request is made, so I can be sure that a given change is probably not going to break my software. And yeah, I don't have to manually run pip compile every time to generate this file. So what kind of classes of attacks can we prevent with notifications? Well, they don't really prevent any of the man-in-the-middle or typosquatting dependency confusion attacks. They don't really prevent being a target of research or getting SolarWinded either. I think those are fairly hard to prevent, but if they do happen and we become aware of it, these kind of tools will basically immediately or as soon as possible notify you that you're using something that is known to be compromised and have a faster upgrade path. So it's as easy as hitting merge to make yourself more secure once a vulnerability has been found. So let's talk about some other improvements. Like what else can we do to fix this? And I'm going to outline some things that have been proposed in the past or are potentially in progress now and sort of discuss why they are or aren't great ideas and what we're going to be doing there. So one improvement that gets floated a lot, all the time basically, is package signing. So basically the idea that a package author can sign their package, upload that to PyPI, include a signature, and then every time that you download it, you verify that signature and you're good. You know that it's legit. So there's a definitive post on package signing that Donald Stuft has made about why package signing is not the holy grail. At the end of the day, there's a couple problems here. First, it doesn't prevent the whole series of attacks like SolarWinds. SolarWinds, that software was signed perfectly. There was nothing wrong with the signature process there, and they still got compromised. So it doesn't prevent that whole class of attacks. It could potentially prevent the dependency confusion attacks, but so could hashes. And the thing about things like GPG is that not only are those tools fairly hard to use for new users that just want to publish something on PyPI, they are also built on a web of trust. And at the end of the day, you have to also trust that the signatures that you're verifying are actually the people that have permissions to publish that software. And so it's sort of just shifting the trust around a little bit. So I would encourage you to read Donald's post. He goes into a lot of detail about why currently you can upload signatures to PyPI to go along with the packages that you've published there. In practice, I don't think a lot of people are actually using this. Another improvement that sometimes gets floated, let's have a fully audited and curated PyPI. So basically this means, let's say every package that gets uploaded to PyPI, someone looks at it, they review the code, they make sure that it's not malicious, and then they say, right, this is available for everyone else to install, hit publish. The problem with this idea is that one of the reasons why PyPI is successful is because anyone can publish to it. It is an open ecosystem and an open repository, which in some ways makes it a little bit like the Wild West, but in other ways makes it very welcoming and really lowers the bar to who is able to publish software. We've worked on that, improving that for a really long time, right? That is a goal. Like we want it to be easier for folks to publish software. In my previous PyCon talks, I said something like PyPI is now so easy that spammers can do it. And it's true, right? Lowering that bar also introduced the potential for spam and script kiddie type of stuff on PyPI. But that's a trade-off. And the trade-off is that at the same time, it's also a lot easier for everyone that legitimately wants to publish actual code on PyPI as well. And that's actually what we're trying to get. There are software distros where their package repositories are fully curated. That's a lot of work. At the end of the day, it ends up being a ton of work, and it's not something right now that a team of volunteers that support PyPI or the small PSF staff would be able to support. Another improvement we can make is basically furthering the slow but inevitable death of the setup.py file. So if you're not familiar with setup.py, basically every package that's published on PyPI usually contains a setup.py file, and this file is executed at install time. So when you download a package from PyPI, this setup.py file is executed, and at the end of the day, you can do anything in that file that you can do with a Python package, and that thing happens on the user's machine when it's installed. So that's how a lot of potentially malicious Python packages can be created, is by running some arbitrary scripts or shell commands or something from setup.py at install time, right? You don't even have to import the package in order to potentially run something that's malicious. So there's a move towards making source distributions and things that are published on PyPI more static and not require code execution to install or execution of the package itself. This wouldn't fully absolve us of any potential for malicious packages on PyPI, right? You could still have something malicious happen when you import or run certain functions of the API of the package. But this does sort of prevent things that could happen with Typosquatting, where you accidentally type the wrong thing and then you're like, oh, what did I just install? You wouldn't have to worry about that as much because setup.py wouldn't have been getting executed. So we're slowly moving towards this. It's going to take a while because setup.py is something that we've centered on as a standard for the language ecosystem, and it'll take some time for sure. Another improvement, better docs. I mean, let's be honest, we can always use better docs basically everywhere. We actually, I think, have fairly good docs. So the Python packaging user guide, which lives at packaging.python.org, is actually a really nice guide for how to do Python packaging. One thing I think we could improve here is being able to better inform users about the power and potential that their tools give them, right? I don't think actually restricting something like pip's ability to install any single package on PyPI or from any repository is a good idea. That's one of the reasons why pip is successful, is because it is such a powerful tool. But at the same time, we do want users to know that there is potential for misconfiguration. There is potential for using the tool in a way that could make them vulnerable. And I think, me giving a talk like this helps with that. Documentation and best practices also really helps with that as well. And I'd love to see a section in this guide also specifically about supply chain security. Some of the workflows that I described and things like that would be right at home there. Another improvement that's happening and actually in progress is the integration of the update framework into PyPI. So the update framework is a bit like hashes, but better. So it's based on PEP 458, which is a way to secure PyPI downloads with signed repository metadata. So this is a bit different than package signing itself, because packages here are signed by the repository and not the author. So this is like a more secure way to verify what PyPI is serving you is actually what you want to install. However, Tough does allow for the ability for package authors to also sign as well. It doesn't help with the web of trust or anything like that, but it does give us another avenue towards actually having fully end-to-end signed packages. This is in progress. We have some folks working on this right now. The National Science Foundation actually just gave a large $800,000 grant to the New York University and some folks working there to help improve Tough and also integrate it into PyPI. So watch this space. That's going to happen over the next couple of years, I think. Another improvement that we can make that I think would really help with supply chain security on PyPI specifically is introducing namespaces. So this idea was actually, we've been thinking about it for a while, was introduced by a user as an issue on Warehouse. And basically the idea is that we would be able to add some confidence that a certain package is owned by a certain entity. So right now, anyone can go and register a package that starts with Amazon or something like that. A namespace would allow us to enforce that, let's say, every package that starts with Amazon dash is definitely owned by the Amazon team, and you can install those with confidence, right? And you can also restrict that, if you're installing certain packages with Amazon dash, they're only coming from that team. So namespaces would be powerful. A lot of other repositories have them. You can sort of think of namespaces like users and organizations on GitHub, right? You can have multiple namespaces and then sort of the same project name within them. This would also open up the potential for a lot more packages, and on PyPI, the more packages name would become available because they would be under namespaces. But yeah, generally this would just help improve confidence in who owns what package when it's being installed. We sort of have to retrofit this onto some of the existing tools and tooling, and we think it can probably be done, but it will be a fair amount of work. We have a lot of projects like this that we have sort of outlined and have ideas about, and we need help, basically. So one improvement that we can make is just increasing funding for projects. Like I said, we have a long list. If you go to psf-/fundable packaging improvements on GitHub, there's a long list of packaging improvements that we've outlined here that are maybe not quite on the roadmap, but we think could be funded and would be really useful for the community, for package security, and all those kinds of things. And increasing funding here, having more organizations step up to help fund some of these projects would go a really long way. On PyPI, we have a good history of the last couple of years now of bringing in grants to work on projects like this and successfully land them to great benefit. So just generally an improvement we can make is more funding here. And to toot my own horn a little bit, I'm really proud that my employer, Google, recently just gave the PSF a large grant to do some of these things. We're going to build productionized malware detection for PyPI, doing some sort of static analysis, make some general foundational tool improvement for packaging, and some other things as well. So I'd love to see more organizations step up like this to this degree and support these projects and help improve the general ecosystem as well. All right, thanks for watching. I also want to give a huge thank you to the PyCon staff, as usual, for everything that they're doing, all the hard work they've put into making this online event super successful. I'm really impressed, and it's going to be really amazing. They absolutely deserve all of your thanks as well. So please be sure to reach out on Twitter or via email and let them know that you appreciate all the work that they've been doing to make this event successful. See you all next year.